Hey everyone, welcome back to my channel. I'm Neil and I'm really excited to share today's video with you. Before we jump in, please hit that subscribe button to support my channel. It means a lot to me and helps me keep making great content for you. Okay, without further ado, let's get started. We have this sequence 1, 5, 11, 19, 29, and we are going to find the nth term or the rule of this sequence. The first step is to find the difference between terms. 1 plus 4 is 5, 5 plus 6 is 11, 11 plus 8 is 19, and 19 plus 10 is 29. So you can see this is not a constant for 6, 8, and 10, so we don't have a linear sequence. So we should continue finding the difference. 4 plus 2 is 6, plus 2, 8, plus 2 is 10. So this is a constant, which is 2. So it means that we have quadratic sequence. What is quadratic sequence? This is a kind of sequence where the pattern of the numbers follows a second degree rule, something involving n squared. And the general form of quadratic sequence is an squared plus bn plus c, and a is not allowed to be 0, because if a is 0, 0 times n squared is 0, so we have only bn plus c, which is not a quadratic sequence, it's a linear sequence. Okay, and now the next step is to use this constant, which is 2, and divide 2 by 2, which gives us 1, and 1 is the value of a. So we built the first part of this nth term, which is 1n squared. Okay, and then we should rewrite terms again. 1, 5, 11, 19, 29, and then use a, which is 1 here, 1n squared or n squared. Okay, plug the first term, which is 1 here. 1 times 1 is 1 times 1 is 1. And substitute 2. 2 squared is 4. And continue for 3 squared 9, 4 squared 16, and 5 squared 25. And then subtract 1n squared from terms. So term minus 1n squared is 1 minus 1 is 0, 5 minus 4, positive 1, 11 minus 9 is 2, 3, and 4. And you can see we have another pattern here, 0, 1, 2, 3, and 4. And if you follow this pattern, you can see the difference is 1, which is a constant. So we have a linear sequence for differences, and the linear sequence, the general form of that is bn plus c, and you can see that we have this constant number, which is the value of b. So we have 1n. Okay, for the first term, if you plug 1 here, 1 times 1 is 1, but the answer should be 0. So we should subtract 1 from this bn to find 0. So you can build this 1n minus 1. If you substitute 2, 1 times 2 is 2. 2 minus 1 is 1. If you substitute 3, 1 times 3 is 3. 3 minus 1 is 2. Okay, so we have, you can consider this b of n. Okay. And the only thing that we can do is to rewrite. A of n is 1n squared, the first part, and the second part is here, plus n minus 1. This is the nth term of the sequence. And you can check your answer. If n is 1, 1 times 1 squared plus 1 minus 1 is 2 minus 1 is 1. And if n is 2, 1 times 2 squared is 4 plus 1 3. Plus 1 5. 5 minus 1 is 4 plus 2 is 6. 6 minus 1 is 5. And for n, which is 3, 1 times 3 squared plus 3 minus 1 is 11. So you can see the first three terms is 1, 5, and 11. So our answer is completely correct. I hope you enjoyed this video. See you in the next one. Bye bye.